Sure. Um, for today class, I'm using this book one, principal processes, to chapter 7, through type 5. Energy and energy balance. So energy is expensive. I have not yet learned how to efficiently, seemingly, use efficiently the seemingly endless supply of free energy provided by the sun, wind, and tides. The nuclear power generation is feasible, but requires safe disposal of the radioactive waste. So, as an engineer who design and operate the system, so one of the principal job would be to account properly for the energy that flow into and out of each process to determine the overall energy requirement for the process. You would do this by writing the energy balance on the process. It's similar to material balance, which account for the mass flow to and from the process. So a typical problem that may be solved using the energy balance is one example is how much power is required to pump, let's say 1000 liter per hour of water from a storage vessel to a process unit. What else? How much energy is required to convert 2000 kilogram of water at 30 degrees C to a steam at 150 degrees? So all of this question can be answered by energy balance. So form of energy. So after completing this chapter, we should be able to do the following. First is to define in your own word the type of form of energy transfer between system and its surrounding. To calculate the kinetic and potential energy from a body of mass when it moving or at certain elevation. So kinetic energy is an energy due to the translational motion of the system as a whole relative to some frame of reference using the earth surface and the rotation of the system about some axis. We have potential energy. So kinetic energy is this book they use EK or symbol. Potential energy is EP, internal energy is U. So potential energy is energy due to the position of a system. Potential field, such as gravitational or electromagnetic field. Internal energy refers to energy possessed by a system other than the kinetic and potential energy. So this energy is due to the motion of movement. So this for internal energy, it's usually happen in a closed system due to the motion of molecule relative to the center of mass of the system. with the rotational and vibrational motion and the electromagnification of the molecule and with the motion and tension of the atomic and the subatomic, meaning the motion of the molecule when you hit the closed system. It understood like that. Suppose the process system is closed, so meaning there are no mass can enter or going out on the system, but the process is still taking place. So the energy can be transferred between such systems in two ways. It's either as heat or work. So heat is energy to flow as a result of the temperature difference. So different temperature, it's referred to heat. Either positive or negative heat will depend on how the heat is transferred from or to the system. Iceberg is require something or some mechanical thing like shaft. So meaning there will be a force, a torque, a voltage, like the gas expand in a cylinder, which move the piston. So the work is done on the piston by the gas that expand. So energy is transfer as work. Okay. Work like heat is defined as positive if it transferred to the system from the surrounding and vice versa. From the system to the surrounding, it's a negative work, similar to the heat. So the first law of thermodynamics, the principle that underlies all energy movement is the law of conservation of energy, which states that energy can neither be created nor destroyed. The first law states that the rate at which energy kinetic potential is carried into a system by the input stream. So why you need to know this? Later, there's some simple derivation how to obtain the equation for the energy balance, either closed or open system. The principle is similar to thermodynamics that you have learned before. Kinetic and potential energy, the equation referred to 7.2-1 in 7.2-1b. So 7.2-1a is the normal equation 1 over 2 n square. So if the mass in this case is flow rate, 7.2-1b, so the symbol for kinetic energy must have this dot on symbol. When the M, that one refers to the rate. So what is rate? It's over time, second, minute, hour, day. Example 7.2-1, 7.2-1, page 359. The water flow into a process unit through 2 centimeter IB5 at the rate of 2 meter cube per hour. Calculate EK, the stream, in joule per second. Notice the unit changes there. First, calculate the linear velocity or U. So to calculate it, we just need to divide the volumetric flow rate 2 meter cube per hour with the cross-sectional area of the pipe, which is pi 1 square is in meter square. The one is equation for circle. And that this is referred to unit conversion. In conversion, you can refer to the book, Appendix A. Have the physical book. It's the first, the yeah, the cover of the book. So U equal to 1.77 meter per second. When we identify the rate in dot. This is density for water. Although density of water, this is the assumption 1000 kg per meter cube. But actual density of water is depend on the temperature. You get it, you can refer to appendix B. Appendix B. Yeah, refer to the book. Yeah, appendix B. Appendix A for unit. So we have a 0.556 kg per second. In question 7.2-1b, then we calculate the kinetic energy, which is 187 joule per second. This is unit condition. This is equal to U. So we have exercise. You can try this exercise. It's straightforward. So how to do this? Identify the U. How to get the U? Then refer to this method. But in this case, U is given 42. So you need to find the M. Yeah. So to identify the mass flow rate or volumetric flow rate or any flow rate depend on the units. You need to find the volumetric flow rate. So to find the volumetric flow rate, you need to use this equation. Since we have the U already, we need to find this term, first term. Once you identify that term, then straightforward lah. Find the N, can use what? Hmm. Okay. We have EP referred to potential energy. The gravitational record. The gravitational potential energy of an object of mass m is equal to mgz 7.2-2a. And where g is the gravity acceleration, z is the height of the object of a reference plane. For reference plane, you need it's depend on you. Yeah, regardless. Which one is the point number one, point number two. So once you choose point one and point two, you cannot change it for kinetic energy. So kinetic energy will be using the same point one and two. So sometimes when you choose um, uh, the Z is negative, it's normal because it's depend on where is the reference plane. So above a reference plane at which EP is arbitrarily defined to be zero if a fluid enter a system with a mass volume M and an elevation Z related to the partition energy reference plane, then EP equal to mgz. Similarly, this is referred to red per second. So EP may be thought of as the rate at which gravitational potential energy is transported into the system by the fluid. Since we are normally interested in the change in potential energy when a body or fluid moves from one region to another, the elevation chosen as the reference plane does not matter. It's what I say to you. So the EP might be negative. It depends on the reference plane. Example. Crude oil is pumped at a rate of 15 kg per second from a point 220 meter below the Earth's surface to a point 20 meter above the ground surface at the ground level. Calculate the attendant rate of increase of potential energy. So to help you, I suggest you draw it easy to understand so that you know which one is point one, which one is point two. Let's just step one and two denote the first and second point. So in this case, the reference point is 220 meter, 220 meter below the Earth's surface to a point 20 meter. So 20 meter refer to a second point for this case lah Z2. Z2, 20 for this negative. Okay. So AP equal to, okay, this is 15 kb per second, and this is the this is unit conversion, this is the Z2 minus Z1, so since Z1 is negative, we have 240 overall letter EP, it is 1200 joule per second. The answer could also be expressed as a watt or kilowatt. So a pump would have to deliver at least this much power to reservoir the oil at given rate. 5 kilowatt. So exercise. So first thing you need to do is draw. Yeah. So that you didn't mix up the point one, point two. So suppose you pour a gallon of water on a rounding cat 10 feet below your bedroom window. So Z1, Z2 is Z. So the cat is Z2. Z, sorry, yes, Z1 is your bedroom window. Normally like that. So how much partition energy does the water take? So this one is how to calculate. So a gallon of water is a unit. So that unit, this is not talking about a rate. So that unit, a gallon of water, if you're not familiar, you can change to kg. A gallon of water is a unit of ya, belum ya? Ya, okay. Okay, yes, belum. Hmm. So, so gallon of water, hmm, lagi dong. MGZ. So, gallon of water multiply with G is gravity. So this gravity is not 9.81, it's 42 because of the unit. How to know? Appendix A. Appendix A. Saya dah buku ni. Appendix A for the book. Appendix A. Hmm? Ya, appendix B. Ini conversion. Conversion. Oh, no. Unit conversion. Pakat cover. Close the view. Oh, okay. Dia dekat cover. Unit conversion. Since we are using online book, oh sorry. Soft copy. Mesti adalah cover lah. Satu. Boleh Google je lah. Gravity for uh, apa? Pound, sorry, feet per energy per second square. Cik dah lupa tu. Gravity feet per second square. Yes. English mana kan? Ya, 32. 32 feet per second square. So, 1 gallon. Oh, so gallon kena tukar kepada pound. So, gallon per pound. Gallon per pound converter. Banyak sekali. Hmm. Oh, gallon. 5 gallon. 2 gallon. Oh, US gallon, UK gallon. Ah, betul. 10 pound. 10 pound. SD kan nggak tahu. Oh, sedikit ya. Selalu mula cak. So M G G in equals to the unit conversion from um, gallon to pound, then the this Z. So in this case Z2 minus Z1, Z2 is the cat even bawah dekat bawah. Z2 is 10 feet higher than the cat. So Z2 is 0, meaning it's a reference plane, minus 10. So negative 10. So MGZ. And a dot. So how about this P? How fast is the water traveling per second just before the impact? So for the B, you need to relate it to the to a little file. Oh, how fast is the water traveling just before impact? So what? It's traveling at okay. It has to refer back to the gravity. Yeah, it's gravity. So jawapan. Kan dalam buku. Oh, saya cuba. Hmm. So, energy balance on closed system. So the system open or closed according to whether or not the mass crosses the system boundary during the period of time covered by the energy balance. So accumulation is equal to input minus output. So we limit the input and output terms since by definition this is for closed system. No mass crosses the boundary. For the closed system, it is possible, however, for energy to be transferred across the boundary as heat or work. So even though there are no mass or out the system, but still heat and work, yes, can be transferred across the boundary of the system. And so that the right hand side of question 7.3-1 may not be eliminated automatically. So final energy of the system minus initial system energy equal to net energy transferred to the system in minus out. So initial energy is UI equal to EKI plus EPI. And system energy is US. So I is the initial, F is final. EKEP refers to kinetic and potential energy. The energy transfer is in term of heat and work. So Q right? Anda berubah dulu pun. Q refers to heat, W is work. Uh, so combine this equation, we get 7.3-3. Then since this is different between final and initial, so we use symbol. So delta U plus delta EK plus delta EP equal to Q plus W 7.3-4. This is the basic form of the first law of thermodynamics for a closed system. Yeah, but the equation is equal to the closed system. So when applying this equation 7.3-4 a given process, you should be aware of the following. So the internal energy of a system depends almost entirely on the chemical composition, state of aggregation, temperature of the system. So three factors that influence internal energy: composition of the chemical, the state of the aggregation, let's say the liquid, solid, or gas, and the temperature of the system. It is independent of pressure for ideal gases and nearly independent of pressure for liquid and solids. So if no temperature changes, phase changes, or chemical reaction occur in a closed system, and if the initial gas are less than a few atmosphere, then delta U is approximately zero. If a system is still accelerating, then EK is zero. If a system is not rising or falling, then EP equal to zero. If a system and its surrounding are at the same temperature or the system is perfectly insulated, then Q equal to zero. This is what we term as diabatic. Work done on or by the closed system is commonly by movement of the system boundary against the resisting force. Example of the first type of work are motion of piston or rotation of shaft, project the system boundary. So if there are no moving parts, there are no electrical current or no radiation of the system boundary, still can assume W is zero. So all of this rule of thumb for closed system to ease the calculation. Okay. Exercise. What do the term closed system and open system mean? What is an identity process? Exercise given. You do this exercise. Example. Gas is contained in a cylinder fitted with a movable piston. So the initial gas temperature is 25 degrees C. The cylinder is placed in boiling water with the piston held in the fixed position. You see the clamp here. So the heat in the amount of 2 kilocalorie is transferred to the gas, which equilibrates at 100 degrees C and a higher pressure. The piston is then released, and the gas does 100 joule of work in moving the piston to its new equilibrium position. The final gas temperature is 100 degrees C. So write the energy balance equation for each of the two stages of this process. So in each case, so for the unknown energy term in the equation, in solving this problem, consider the gas in cylinder to be the system. Neglect the change in potential energy of the gas as the piston moves vertically, and assume the gas behaves ideally. That one is all the key word. Neglect the change potential energy, assume the gas behave ideally. So it's an ideal gas. Express all energy in joules. So for case 1, the clamp is there, but the temperature rises. So what happened? Refer to equation 7.3-4. EK equal to 0, EP equal to 0, EK because there is no movement, system is stationary, no vertical displacement because of the clamp, and W there are no moving boundaries, so W equal to 0. So delta U equal to Q. Q is 2 kilocalorie. So change the kilocalorie to joule. Conversion. So we get delta U equal to 8370 joule. 8370 joule. So the gas gain 8,370 joule of U of internal energy and it heated from 25 to 100 degrees C. Case number 2, the temperature is 100 degrees C now, but the clamp is released. Release. So the piston moved upward. So EK, the system is stationary at the initial and final state. Delta EP, although the piston is moving, but it's assumed negligible equal to the patient. Delta U is 0, U depend only on T for an ideal gas, and T does not change. For this case too, temperature is still 100 degrees C. So since delta U is related to temperature changes, so we can assume, not assume, we can say that delta U is 0, since this is ideal case. So U equal to Q plus W. W is negative 100 joule. So Q equal to 100 joule. So why it's negative? Because any work done by the system loses heat. And the system that loses energy, so the W is negative. So the heat is equal to 100 joule. So that's an additional 100 joule of heat is transferred to the gas as it expands and equilibrate at 100 degrees C. For exercise, write and simplify the closed system energy balance 7.2-4 for each of the following process. Try this exercise. The first question will be given the answer. We say content of the flask heated from 25 to 80 degrees C. The system is a flask. So this is a question from the closed system. No moving part and due to the zero on station system is stationary. It is zero. No height change in the is zero. So Q equal to delta U. Q is more than zero, so it is transferred to the system. A tray filled with water at 20 degrees C is put into a freezer. The water turned into ice at 25. When the substance is being just put on its surrounding and the contract the surrounding do work on it. So, you could try that pizza. Video will be uploaded in